Hello, Gophers! So, my name is Dominic St-Pierre. You're listening to Go Podcast. I'm a good old software engineer. I would call myself a standard programmer and whatnot. I just have a lot of fun. I do a lot of stuff. If I had took the enterprise, path, I would probably not be writing code at the moment, but, why write documents when you can still write codes? So I'm more like an indie software engineer, I would call myself. This podcast, is about Go. Today, I want to look at something, some tools that we are all used to use for static analysis and linters and whatnot, like GoVet, Revive, GoSec, a couple of things like that, static checks and whatnot. We are kind of using them before putting our code into production. And I'm not a huge paper reader myself. I'm trying to do that more and more. And one that caught my attention was one that was, telling something like, your vetting and linters tool might not be as good as you think. So let's unpack that a little bit. So the paper is called Assessing Golang Static Analysis, I guess, Performance Against a Real World Issue or something like that. Very, very close to that. So, I mean, first of all, I'm not even sure what a paper is. If you ask me right away, Dominic, what is a paper that is published at a university? My guess is that I think it is related to people, students that are doing PhDs that need to publish something to get their PhD, I guess, or anyone in the field that. I'm not sure I would be able to publish that myself. So it was published at the University of Delaware. So but the fact that they use Golang in the title is kind of a small warning sign for me. I don't know, it's strange. But basically, what they did is that they surveyed a lot of developers, programmers, software engineers, and they ran a bunch of static analysis tools and linters against, well-known project. You can think of the Kubernetes and Hertz, a couple of big projects in the Go world and whatnot. So what they wanted to do with that is basically try to answer two questions. First of all, is the tools able to properly found the issue, or at least indicate to the developers that there's something to be done? And second of all, how effective are those tools to help the developers or programmers, whatever, find the real solution to that? And this is a little bit of a shock. I haven't seen and heard that myself and things like that. I don't know who they surveyed and whatnot. I don't really have much detail about that. I just know that it seems to be legit ultimately, but at the end of the day, it seems like programmers are saying that they might not have all the information needed from the tools to properly fix all the real world issue. Let's put real world in bold here, because it's mainly what is going on mainly. Personally, I'm all good with the tooling that we have. I'm generally able to fix most of my reported issues, and even though sometimes yes, I have seen some false positive here and there. I've been doing Go for that long that at the end of the day, you kind of, at some point, you know what you did. But I can understand that maybe the tooling could be better for people that are jumping from another language to Go and things like that might not have seen all the intricacies and things like that. We will see that as we go a little bit deeper in the study itself. So the first thing that they found is probably obvious to a lot of you, especially if you are doing Go for a certain time. So let's take a little bit of a step back. So they analyze like 2,000 pull requests across 20-ish popular projects to try and try and determine some categories for those things. And the most popular issues that they discovered is, and it's the weak reference, the for loop that if you are using a pointer inside your for loop that points to the thing that is loop around. So let's say for R range request, for example, and you are using an ampersand-R to get the the address of the pointer for that thing. So before 122, it was using one single address for all the looping elements. So basically you were kind of screwing your code around because you were kind of reusing all the same value as the last thing that you were ranging over. I don't know. You know what I'm talking about, right? So, and I can understand that it's pretty difficult for a linter or I'm not sure if that thing would enter the linter or static analysis tool. Which of those? Probably the static analysis, I would guess. But again, I'm just a normal programmer, man. I do business stuff. I'm not sure, but I would imagine I'm still I can recognize that it might be difficult to find. And it's important that I think that they mentioned that, because even though that Go 122 fixed that thing, there's a lot of there's still a lot of software out there that is not using Go 122 yet. So even though it's pretty easy to migrate or to upgrade the compiler version, there's a lot of probably internal tools in the back corner of some companies here and there that haven't been built since, like, I don't know, 7-8 years. You know how it is. It's always like that. And Go is notoriously good for that as well. It's a build it, test it, and ship it and deploy it and never touch that again sometimes. So but again, if a service or kind of tool, internal CLI, whatever, if this thing is running for 8 years, you probably do not have any bugs in there. If the weak reference would have been there, it would have been probably caught already, hopefully. Otherwise, well, nobody's using that tool. So again, so really nice job for the Go core team to have implemented that fix. I cannot stop telling, or at least remembering, how many. It's always the same thing, when someone is starting with Go. This is one of the things that were kind of always happening. If you recall, if you put yourself into your own shoes when you started Go, I'm sure you have done that. This famous loop at some point with the pointer. So very hard to detect because yes, but not only that, but this problem is fixed now, and it's very easy to just rebuild update the Go compiler with the backward compatibility guarantee. There has to be there has to be some easy way to fix that one. So again, not terribly shocked about that. So let's see the next one. The second category of issues that were not really found by all those tools, and to me this one is the craziest one, because let's face it, the weak reference that we talked about just above, were even before the Go 122, we were having some easy fix, right? You could just have an index in your for, so for I, comma R, equal, semi-equal range request, and now you could just do request in bracket I. So that was an easy one. So the second one in popularity, and believe it or not, and I have a hard time believing that. So imagine that having some kind of file opening, for example, or file reading, or any kind of IO, or any kind of things that should return an error, and there's no if error not equal nil underneath. That is a shocker to me. I haven't seen a lot of bigger Go code base myself. Personally, I've never really opened Kubernetes and things like that. I'm not very interested into that myself. I'm pretty shocked to know that, and I'm not saying that Kubernetes had that. It's just that they investigated 20 known open source projects. I don't know which one, but I have difficulties believing that at some point someone opened a pull request and that pull request was accepted without having an if error not equal nil underneath. Maybe I'm wrong. Tell me I'm wrong or something like that. I mean, I cannot believe that we are there. It's the first thing that you start to do. Always, all the time when you start doing Go, and most of the time, after a couple of times, you start to be kind of a fan of this situation, because, I mean, you're preventing your program from panicking at the end of the day. And so maybe it's just like small, piece that were forgotten, but how can you do that? How can it be forgotten? Because that's you still need to defer a file opening, calling the file.close and things like that. Man, I'm super I don't have the word in English. Damn, I'm surprised. Let's just say that. But it's way worse than surprised. I'm open mouth, man. I don't understand that one. So the last category that they categorized into 3 categories. The last one is like a loose Boolean check, and that one I'm not super surprised. When you, I mostly have seen that for JSON object or structure in general, using the equal sign instead of using a deep equal, or something like using the reflection and whatnot. I mean, I'm not surprised to hear about that. I'm surprised that it's kind of popular though. But again, we are talking about situations, or like they said, real world issues that were not caught by our toolings at the moment, and they probably should have. So that one, that one I can see that. I don't have a lot to say about it, to be frank. It's it would be great if the tooling were to improve and whatnot. But like I was saying and keep saying, I don't think we have probably the cream of the cream in terms of the tooling already. I would say, although it's not a secret. I've been doing a lot of Gleam lately, and the compiler, the error messages, the things like I really enjoy. So I mean. But Go isn't a functional programming language, so you cannot really have as much. It's way different. It might be, and I'm not a language creator. I don't really know exactly, but maybe it's easier to do some things in functional programming in terms of analyzing the AST or whatnot. I mean. Maybe there is some differences, and I'm not aware of that. No, I don't have any. I don't have any intention or desire to write my own language or even a static analysis myself. I was going to try to write something. You know, I have this small helper library that I called TPL for the, you know, kind of replacing the HTML template myself, or at least sit on top and just having some more a more fun time with my life than using the standard library one. And at some point I wanted to try and see if I could build a static analyzer that would parse the template and check the type that this template is receiving. Even though it's all dynamic, it would have been a you know, a separate CLI that would have done that at compile time probably, but completely outside of the code of where the templates are. And damn, yeah, it's difficult. It's not an easy. It's not always easy. So I can imagine that those tools. I mean, it's kind of normal that they there's a couple of scenario or you know, like they say in the paper, real world issues that they are not seeing, or at least might not even be possible at the moment, or I don't know exactly, but yeah. I've been doing Go for 11 years personally. Never was a problem, so I don't know. So they surveyed 10 software engineer to principal software engineers. So, you know, not a lot of people, but still, I mean, depending on who they are, might be significant. And yeah, what we can, you know, deduce from that is that, yeah, the linters and the static analysis tool are pretty good to identifying, you know, what's going on. There's still a lot of work to be done regarding what a programmers would need to do, especially for it seems like GoSec and static check, for example. But yeah, again, I mean, I understand that, and I'm not even sure that I would even dare say that I'm agreeing. But I mean, again, I'm just someone that builds mostly software as a service, and I can imagine that in a bigger org, potentially. With a lot of different programmers here and there and things like that. I mean, those tools need to be sharp and precise to make sure that, you know, people that are jumping on a new project, and especially a new language, if they never did something, then yes, it's totally valid to expect some tooling to guide, or at least propose a very, very decent solution to an issue, for example, and things like that. So I suppose that the authors of those tools would expect some some bug reporting and whatnot if there is anything that needs to be improved and whatnot. I mean, it's pretty hard to improve your tool if if not much people reports those scenarios and whatnot. So I mean, I don't know, man. It's interesting to see what is published in a more maybe not scientific, but let's say it's still a university paper. So I mean, there has to be some research done before publishing this. But yeah, it's I don't know. I really like the tooling that we have, and it's pretty impressive what we have so far. So I'm not saying that this paper is not saying that, not at all, but yeah, yes, I don't know if it can be done even at this point without maybe using LLMs and whatnot. I mean, at some point, maybe there will be some kind of mix between good old algorithm static analysis and LLMs that would check the code and try to extract some truth out of that. Truth being there might be some issues here and there and things like that. I don't know. All right, on that's the episode. Thanks for listening, and see you next time.